Hello, everyone. Thank you so much for joining us today. My name is Alexander. I am a Google Developer Group lead in Waterloo, Canada. And today we have a special guest for you all, Noble, a former Google Developer expert in ML. And essentially, like to briefly talk about today's event. So this is our second event in the Build Your ML Portfolio series. And 2 weeks ago, we during our first event, we covered all the ML basics. So feel free to go and check that out either on our YouTube channel or on LinkedIn. And today's topic is about building sensitive info detector with NLP. So and this session is a workshop to help you build a basic project with NLP, and then after the session, feel free again to combine different sources and build an enhanced version of this project, and it can become your portfolio project afterwards. And just as a small note, although this is a workshop, you don't have to follow along. Feel free to use the event recording afterwards to revisit all the concepts that we cover. So, yep, that's essentially a short introduction. And Noble, take it away. Thank you so much for joining us.
All right, let me share my screen. I should probably.
Okay, yeah, while we are doing this, again, I will share a Google Developer Group link. So for the future events, as I mentioned, this is a series of workshops. So in 2 weeks, we hope to host another workshop about computer vision. So, yep. Philip, please do subscribe. I will share it in the chat here. And yeah, okay, great.
All right, hey everyone. Alex, can you confirm you can see my slides?
Yep. Yeah, everything's good.
The entire screen, correct?
Yep. Yep.
Awesome. Thank you so much, everyone, for investing your Saturday to learn about natural language processing. First, a little bit about me. I'm the person you're seeing on the screen. Hopefully, that's apparent. I lead product at a technology consulting firm in Virginia called Ventera Corporation. And for my day job, I'm hyper focused on helping our customers responsibly deliver machine learning solutions, tools, and build solutions to help them trust the results of their machine learning enabled software. I'm, as Alex said, I'm a former GDE, and a fun fact about me is that I'm racing in a Spartan race, an obstacle course race, trifecta, in June, actually in maybe a week and a half, and I haven't raced, and so I'm freaking out. And so this is probably boot camp to get me prepared. And so today we're going to learn about natural language processing, or NLP. And what is it? It's a technology that simply teaches machines to understand human languages. Specifically, we will learn today about how to use an NLP model to teach a machine to recognize when a human or when someone shares any potential sensitive information in a consumer or enterprise system. So you're not supposed to share your passport number when you're booking a flight, perhaps through their little chat system until you have a secure portal. This is one way to sort of detect and extract that and maybe do something with it, right? I should note up front that there are a lot more robust off-the-shelf products to do what we're about to do today. Google Cloud, for example, has something called data loss prevention. I think it's called Cloud DLP. That will solve your problem as far as listening for people accidentally leaking sensitive or protected health information or even personally identifiable information in systems. There are open source solutions as well. But I chose to use named entity recognition, which we'll get into here in a second, a form of NLP, to help you with a few things. One, I want to give you foundations on natural language processing, specifically, again, something we call named entity recognition. I want you to familiarize yourself with real world use cases in the field with NLP and natural language understanding. This is not, when I say natural language understanding, some people might attribute that to generative AI, which we've all heard a lot about. This is not an NLP, a Gen AI talk. This is not a GPT talk. But going through these fundamentals will help you better understand the terms, tokens, and vectors, that kind of stuff, and the techniques used in large language models today. And it will help you mentally map what you're doing. So if you want to go out and start from here, these fundamentals, and then go out and build your next GPT plugin or whatever it is, you have the basic understanding. And then, of course, the final benefit here, and the reason why I chose this path to teach NLP and named entity recognition, is so that you can take this, run with it, build your own portfolio with a machine learning product grounded in real world use along the way. Okay. The workshop is structured into 3 areas. I'm going to Quentin Tarantino it, right? Like, we're going to start with a demo. It's a very short demo. And then we're going to walk through the process of how we got to the demo. And then we're going to end with real life use cases, which you should sort of have in mind as you're thinking about how you apply this with your own example project to continue. Okay, so let's get started. As I promised, the demo. So for my day job, I'm gonna sort of minimize. I don't know how I'm gonna do this, but just focus on. Let me blank out this screen. All right, so focus on this little modal that I have here in the middle, locally running here. My day job, I work for some large enterprises on the federal side and on the Fortune 500 commercial side, right? And these enterprises often support tens of thousands of users, especially with their public applications, and have a lot of work. They incur a lot of effort to sort of mitigate and leak sensitive information. Their entire business units dedicated to protecting user information. Okay. And so, for example, if you're a customer of a large financial firm or a retail company, a customer accidentally posts their credit card number on a support site. So we're looking at this here. This is a health page, and I want to say, how do I use Giphy? How do you spell Giphy? It will sort of give you an example of how to use Giphy, that kind of stuff. I'm glad that worked. But if let's say you had a user that posted in this modal a credit card. So he says, hey, my credit card, if you can see, it's kind of tiny at the bottom here. Why is my credit card not working? I keep putting in fake credit card, by the way. This is not real, I hope, in the form, but it keeps rejecting it. This is a no-no, obviously, so you shouldn't do that. And so, as you can see, that's the intent that I want to sort of send to, I mistakenly leaked my credit card. The system tells me that it can't help me with that, and the credit card details have been deleted, and it sort of references the last 4. Mm-hmm. So it wants me to also contact customer support. So in theory, this transcript is going to be sent to a security AppSec person in the background, and a human in the loop is going to verify that the leaked sensitive information has been purged, and sort of send a confirmation so that this fictional company, is in compliance with local legislations and the like.
And Nopal, sorry, just to pause you. Essentially, just to clarify for the audience, the the objective of the session isn't to build like a chat bot or anything like this. The objective is actually to build a model, right, that will help you detect all the sensitive information like in the text that you input, right? And then after again and again after this workshop, feel free again to incorporate this into a website or a chat bot or whatever you want. Yeah, but just to clarify, what we will learn today is actually like building like machine learning aspect of it, if that makes sense.
Yep.
So, yeah,
Yep. So recognizing this part.
yeah,
I
yeah,
like how when I sent it the second time, it changed how it wrote it. It recognizes, it has, it pays attention, knows that it has already explained it to me, and I posted the same message again. So it starts getting a little assertive. I love how machine learning is very random and non-deterministic. So I hope today's demo will go. So will go well. Praying to the demo gods. So that's sort of the overview as to where we're going to go. Again, we're starting at the end and we're going to see how we get there. To do that, I need to dig in a little bit more about what is this NLP thing, right? I already explained it as, teaching a human to teaching a machine to learn human language, right? Well, NLP is actually not new. It's been around for about 70 years, right? There's just the techniques and methods that we use to improve it has changed over time. And within the last several years, since 2017 or not, that has even accelerated even more if you've been paying attention, right? No pun intended there. So in simplest terms, we're teaching a machine to understand human languages. A machine gets an input, right? Either through speech or text, and turns that into numerical representations, or sometimes they call those vectors, so that a machine can understand. So machines are really good at zeros and ones, right? And then in turn, based on what we do after the vectors are processed, we can then use outputs for classifications, recognizing certain entities that we care about. So pay attention there. That's what we're going to be focused on today. And then recognizing entities for our text and speech, one of many outputs. I mean, you can do so many things with that. And even with generative AI today, they're infinite. I don't even know what can't be done with it yet. And we're still in the early stages of understanding the power of natural language processing and understanding with larger language models. All right, so I promised you we start with the demo, we go through the process, and we end with use cases. So this is the process. This is what we're going to go through with the process. I may jump back and forth between code and slides. So follow along, and please let Alex know if there are any questions, okay? All right.
yeah. Feel free to submit them in the chat, and then we will ask them. I'm a representative of the audience here, so yeah, don't hesitate to throw the questions. Yeah, yeah.
Right. And I told Alex yesterday, I don't like an hour-long session, hour and a half long session. I don't want it to be a monologue. And that'd be boring for me. I should also mention that doing an end-to-end NER, or named entity recognition app, is kind of impossible. So I'm going to intentionally, and I'll let you know when I cut corners. This normally takes weeks in reality. But at the end of this, you'll be better nerds, right? Named entity recognition developers. All right. So I know some giggles in the crowd there. I'll be sharing slides, and I'm sure Alex will share the slides in the Colab notebook, and I'll share additional resources at the end of this. All right, nerds, are we ready? All right, great. All right, so normally I'm doing this in real life, where people are like just rolling their eyes at my horrible jokes. But I'm a product person. As I mentioned, I'm a product lead. And so when I lead teams to deploy machine learning, I always start with, just because we can doesn't mean we should. And all the engineers who just want to start banging on code sort of roll their eyes and they get tired and they go, all right, what? In the real world of applied machine learning, we first need to identify if our problem even needs AI. AI is expensive, complex, and computationally just ridiculous sometimes. And so we need to take in consideration, say for example, if our boss came to us, or team lead comes to us and says, hey, we've got users in our system, they keep accidentally pasting their credit card information or software license keys or credit card, whatever it is, within our help desk portal, and we need an AI to fix it. My first question is, have we tried other non-technical means, like putting a big warning with a validation script in our front-end client to say, you cannot add credit cards? That literally would be the solution in my view. But sometimes phone numbers and other sensitive information, just like a string of phone numbers, say, for example, some people might encapsulate, parenthesize the first 3 digits. Some people may not. Some people may use dots. So credit cards are, rule-based solutions to detect some of these characters may not be the best solution. It may get very, very complex with nested conditionals and for if then else and when statements and all kinds of stuff, right? So you want to ask, can I solve, how are people solving this problem without AI? If sometimes the answer is no, but in that event, you might say, all right, well, can we solve this in a unique way? So the 2 things that you want to look at, you want to look first at, your user and understand, work with your researchers to understand, how your users are interacting with or without an AI to solve your problem. So for example, and when I say users, you're also looking at people like your security team, right? Like, how are they reacting? Are they more reactive? Are they overloaded? Maybe an automated solution or augmenting their workflow with an AI may be the way to go. All right, so you have to start thinking about that before you start coding. If it's a research project or just a toy project and you want to kick the tires and see how that works, none of this matters. But this context for this workshop is we're preparing you for real world application, applied AI, right? So you have to do a build buy. Do we purchase additional solutions? Will it bring a necessary complexity? So that's your usage patterns with both how your end users are using and how your team is interacting with it. The next thing is scope. Right. So you want to determine if, again, AI is at all the right solution within the scope and how you get there. Well, first you need data, right? So your boss came to you and says, hey, we need to solve this with AI. You need a lot of data. And we'll go through that here in a second. So where did the data come from, though? That's the question that you need to ask. Who's represented in the data? Who's left out? Do we have the right quantity, the right quality? Might this impact the model's behavior, right? And what's the bar for success? Is there a metric that is like, without AI, this was the bar for success and this was the failure rate? With AI, hypothesize that you will have a specific metric that you have to exceed in order to justify moving from research to productionizing your machine learning model. So I just wanted to cover that. This is relevant to any machine learning project and not just NLP per se. Machine learning is complex. Speaking of complexity, when you land your first role in building machine learning systems, you might quickly realize how tough this is. You're not working alone, and if you're the only person, I apologize. You're working with a lot of teams. You're working with DevSecOps. You're working with machine learning engineering, NLP engineering. You're understanding needs analysis. I just adapted a paper by Google to show how complex ML is. Normally, when you say ML, people think it's just this part in red, but it's this whole part, this whole kit and caboodle. I've just adapted it by adding what I just went over, assessing that the use case, the needs are the right ones, right? All right, so I hinted at the types, and sorry, this shouldn't say use case, it should say the types of AI to consider are for machine learning, the types of solutions techniques you can use if machine learning at all is needed. The 2 types generally, if the process is repetitive and boring, or in this case, it's just something that's just logging or automatically making inferences based on a stream of logs, for example, you may want to have a fully automated AI system. And there are a lot of systems out there. There's an entire class of AI called AI ops, which is more in the IT space, that automation is good. There's also augmentation if it's a high stakes situation, if there's life or death situations, or in this case, there might be some harms that comes with leaking, my personally identifiable information in a public setting. Then you may have to choose. So these are some really tough trade-offs that you're going to have to make. And there's no one right answer. All I'm going to say, an opinionated take, that regardless of whether you take either of these paths, a human has to be in the loop. Okay. Because again, AI, machine learning, AI is very non-deterministic. All right.
So essentially, just I guess a short summary is that NLP in our case, like it just a tiny portion of the entire project, right? And then also, as you said, there are two approaches that you can take with NLP, right? And I guess how you use them, augmentation, and the other one was sorry,
Automation. Yeah.
automation. Okay, yeah.
So you've got a co-pilot or a duet in Google terms, or you have a great way to sort of show that. A good point is you might choose you might say, all right, we're using Gmail and we're going to use ChatGPT, or we're going to use Bard or some large language model to automate responses to our Gmail client, our email. Well, you might want to be in the loop for that. You might not want to choose an automation solution, because if I get an email, I kind of want to know what the email said, and then just ask the AI to suggest some responses, either as I'm typing, just predict the next word, or like Grammarly does, just suggest a better way to phrase the sentence, make it easier to read. That's augmentation. That's a really good use case for AI, right? It gives me control, right? And that's what some users in some use cases want. So today, just to set expectations, we're going to go over our data collection. We're going to show how we label and annotate your data. It's the boring part. And then we're going to show how we do NLP. That's why everyone here is for. That's why you guys are here for. And then talk about the end-to-end process in EDA, exploratory data analysis. We're going to talk about evaluation of our model and see how it performs. And we might make some mistakes because it's a live session, but we'll try to figure it out as we go. Okay. So the first step is annotation, right? So you've made a decision to go forward because you said, all right, yeah, let's just use NLP to solve this problem. It's too dangerous. We don't want people leaking their credit card numbers in our system, right? Well, the first step is to annotate your solution. There's so many ways, and I'll share some ways to annotate your data, get it ready for training. It's essentially what we're doing during the pre-processing stage. There are so many ways to annotate your data. I like to use something called Label Studio, where I literally go through. I normally have like 500 of these. And I go through and I highlight it. I say, this is a credit card. Whenever you see this is a credit card. And what it's doing here, it's going to create a tuple. In Python, we call it a tuple, which basically is just an array of a string, or a dictionary of a string, and my entity. These right here are my entities. Credit card is not a typical entity. It is a custom entity that I've just created. And an entity is just a person, an organization, a location. And the library that we're going to use today comes out of the box with these 4: person, org, location, and miscellaneous, like a cardinal. For example, if we train this with the base model that our library is going to give us, it's going to interpret this number, this string right here, as a cardinal or an ordinal, whatever it thinks it is. And then That's wrong, right? We want to tag it as a credit card. So I had to create a custom entity here for our annotation. And so now every single time I see this, I will tag it a credit card. I'm going to hit submit. All right, I like that. I'm going to say this is also a credit card. Oops, this is a credit card. I'm going to hit update. In this case, this is Ghanaian is actually a location, right? So that's a loc, $25. Oh, I need a new entity here for money. And so on and so forth. I'm not going to spend too much time here because we're actually going to take a shortcut. We're not actually not going to, this is not by far enough data to do this. But imagine about 500 of these that you have to just painstakingly go through. Let me jump right back to the
Essentially,
slide.
we like label each data, like I guess each word or some piece of text is part of preparation for model training. Is that
Yeah,
right?
yeah. We're trying to seed it with what it knows and what we know it doesn't know. And so, not to sound like Donald Rumsfeld here, but credit card is not typically something that it should know. So whenever it sees a string like this, or maybe a string without the spaces in between, we're going to use that to annotate a body, a corpus of text, and that's going to go into our training data. We're going to split that into a train test split and say, 30% of this is going to be our evaluation or testing data, and we're going to train on 70% of it. Okay. I actually took some liberties today. When I was preparing for this, I had early access to Google's generative AI studio. And so I just used, I wanted to kick the tires. So this is where generative AI might come in to help you with some of the painstaking process of labeling your task if you are unfortunate to be the only person doing data science or machine learning in your organization. So first, I used it to bootstrap my annotation using prompts to ask what named entities were in the sentences that I wanted to use. So in this case, I'm telling it to generate an easy to read paragraph that includes a fake credit card. And it actually did a good job of that. And then extracted it just to confirm. And then I used this in my code, which I'll get into here in a second, to sort of seed my process. And then I used generative AI again to generate a diverse range of sentences, and then aligned it with when my custom entity starts and ends. And I'll get into all of that. I'm showing slides right now just to sort of show you what we're going to jump into so it's familiar when we jump into the code.
There is one question from the audience. So where do you take all of this data from for the training, and do you have any reference for this test data?
Very good question. So remember I said access to data is one of the biggest pain points in any organization. In the case of this fictional example, we're saying that our chatbot that you saw at the beginning, which is powered by, say, Zendesk or some help desk tool, is susceptible to a lot of leakage. Some people might say even your Slack data, right? So where do you get the data, the corpus of tests that you use to train? It's a great question because you just export enough of that from the system that you want to train from. So if you have a problem with people accidentally leaking information to your system and you have that data stored in an ERP system or a database of some sort, a Postgres database in the back end, you basically export that. Your data engineers sort of help you create the pipes to export that or stream that to a tool like Label Studio, or normalize it in a way that you can actually work with. So it depends on your use case. If you're working for a travel agency, it might be from any transactional data from your flights information from your flights app. Sorry for the dog. And so yeah, hopefully that answers your question. All right, so I use Google's Vertex AI, the generative AI studio, to cut a lot of corners. And on the point of generative AI, again, this is not a generative AI talk, but there's a lot of intersections, and I'll show that in a second. I'm very proud of this meme that I created. It was like in my head, and I put it on paper, and I think it works. And for the 3 people that don't get this joke, I'm sorry. Someone in the chat, please explain it. But I find it, I giggle every single time I see it. Anyway, seriously, large language models bring natural language understanding using something called transformer models. And those are important foundations, no pun intended, large language models are foundation models for developing natural language named entity applications. So in this, if you're coming in and you have no idea what machine learning is and what AI is, this image here that I created can sort of explain it a little bit. You've got AI. This is just this term that teaches machines human things like vision, and then you've got machine learning, and within machine learning you've got deep learning, and then within deep learning you've got different kinds of deep learning, like federated learning, like supervised, unsupervised learning, that kind of stuff. All right. Natural language is its own beast. It's been growing in popularity over the last couple of years. It's been around for 70 years. And then more recently, you've got large language models, right? So we're sort of playing in the same sandbox, right? And so enjoy the meme there. So we've annotated our data. We definitely want to use AI for this solution. We're going to jump into code right here, and what you're going to see is we're going to use a library called Spacey. It natively supports about 70 languages in its large language models, and it's an open source alternative to the GCP Cloud Natural Language API. I was told not to use APIs in this session, so we're going to use Spacey. Cloud Language API, Natural Language API supports about 135 languages. So if you have some languages that are not covered by Spacey, you can use the GCP alternative. I wanted to use Spacey because, a couple things. It comes pre-trained with different sizes of model packages, and it even supports its own generative AI wrapper using BERT, which is also another Google large language model that is now supported by Hugging Face, which just type in Hugging Face, a great name for an AI company. Anyway, powerful stuff. Spacey is really cool. And it also comes out of the box with basic built-in named entities like people, organizations, locations, dates from text, and we'll show that off here in a second. If we wanted to extend these capabilities, like recognize a credit card, we would then have to train it to recognize a credit card. In this case, I took some liberties with Will Smith's intro song to his thing, and I changed it up as my input text, and it correctly identifies that West Philadelphia is a place, Noble is a person, so on and so forth. But you'll notice some things don't get recognized. Let's jump right into Colab to explain all that.
So essentially, as in this code lab, like what we'll take the Spacey existing model, right, and improve it. So now that it can detect credit cards, right? Is that?
Yep.
Okay.
Yep.
Perfect.
Good point. Thanks. All right. So here we're doing our basic setup, but this guy is very the big part, right? So we're loading the medium-sized English version of Spacey's large language model. If that makes any sense. I believe I read in Spacey's white paper, large language, this medium MD version is about 137 million parameters, and compare that to ChatGPT's 175 billion parameters, right? So I can run this on my machine without frying my machine and warming my house. up or burning my house down. This, what I'm doing here, NLP spacey load, is quite self-explanatory, but I'm loading their model into a variable called NLP. And for named entity recognition, again, it's going to recognize all the people, places, stuff that that I sort of teased at. So remember this right here in all our imports as we go along. I mentioned in an earlier slide some things that you can do with the outputs of NLP models. Say, for example, you'll see a lot of applications of similarity. So if you wanted to do semantic search here, I'm using two sentences that says the bees decided to have a mutiny against their queen, and flying stinging insects rebelled in opposition to their matriarch. And so the idea here is to see how similar these two sentences are using the power of NLP. And the similarity score closest to 1 is very similar. So if this were the same sentences, it should be 1, is as close to 1 as we can get. So we know this is similar. And you can imagine how you can use that for, search, real world search applications, right? Using cosine similarity or dot product in order to sort of in order to sort of get the similarity. In the inverse of that, you can actually use that for anomaly detection, right? Because an anomaly is almost the opposite of similarity, right? So you can see which sentences are as far away as possible from the rest of your corpus. So I'm not going to explain all of these, but it also can sort of tell you the parts of your speech, right? So I'm saying here, for every token in my document, right, tell me what the parts of the speech are, and it will just break it down. It's like credit card is a noun, thank, verb, that kind of stuff, right? So yeah, this is just all of my text. So now we're gonna try to teach our machine to recognize sensitive data, right? So I brought back the West Philadelphia, born and raised on the playground where Kwame Appiah spent most of his December. So theoretically here, based on what you're seeing, so I've got a string stored in a variable called text, right? And this is what I want to process. I'm just concatenating these. And then the dock side of the house, this is the line where the actual processing happens. This little image here sort of shows us a little bit about that. NLP is a callable variable instance of spacey language model. In this case, we defined it earlier. And then when you call it with a string of text as an argument, it returns something called a doc object. And this is very powerful. And you'll notice that the doc object is going to have little, the details of the entities, the people, places, things that we care about. And in that case, just to show the power of that, oh no, hold on, I didn't run something. I prayed to the demo gods, didn't I? All right, great. So we passed it this text. And I wanted to do it the simple way first to sort of show off what some of these entities mean. So in this case, West Philadelphia, we know it's a place. Kwame, we know that's a person. Date, Mennonite, we know that it's not a nationality per se, but it's a group of people, right? And so that was just to sort of show the power of that. But sometimes when you are doing your exploratory data analysis, you may want to visualize better, right? So we're going to use, I love this other library that is supported by Spacey that essentially is doing a couple of things. Let me try to break this up. First, we're going to try to, if you noticed up here, I didn't talk about it, but I loaded the Jupyter or the Python HTML renderer, and then I also uploaded. I also imported the Spacey library. So that's what's doing the magic here: the renderer and the library to render our doc object entities, right? We'll choose the style of our visualization. So the style is an entity. So these are basic entities. But you'll notice something, and then of course we render it. You'll notice something that, okay, all of the built-in entities are recognized using the I'm jumping back and forth, I apologize, using this model, the N-Core Web, the English medium-sized model. But I promised you that we were going to try to recognize credit cards. It didn't recognize credit cards. So this is where custom named entity recognition training comes in.
Mm-hmm.
Right?
So essentially, everything up to point 3, right? So everything that what we've done so far in this code lab is we just saw how Spacey model works, right? And now essentially this is the place when we start to I guess add this customization to the model, right? And train it additionally, kind of. Mm-hmm.
Even one step further, we're actually not even customizing their model. What we're going to do is a very good thing that you just said. We're going to actually create a blank model, an empty model, right? It knows nothing about the things that it previously knew. It doesn't know what a place is. It doesn't know what a person is anymore. We're going to use an empty model to start. Okay. And we're going to sort of set up our pipeline. And by the way, this is the pipeline. Okay. We're going to set up our pipeline. And at this point, I probably need to bring my notes up, but we're going to set up our pipeline and then we're going to create a label. All right. And our custom label is called credit card. Now here, traditionally, you would sort of import some text, and I'll show you how that works. You sort of ingest your data stream from whoever asked that question before from your system to a data lake or something like that, a place where it's, you're annotating. Label Studio allows you through an API call to sort of ingest the stuff so you can actually sort of render that here. For the sake of this demo, I'm creating a tuple of strings and our entity, and these parameters are an alignment of when the custom entity that I care about, credit card, begins in the sentence and ends in the sentence. And all of that is done for you when we, remember, labeled our data earlier, right? All right. And so I may have already, I haven't run this yet. So that's our data, right? Mm-hmm. And then we're going to train our model, right, from this train data, right?
Actually, just a small note, sorry to interrupt. There was one question about a link to the data that we will use during this workshop. Essentially, all the data is incorporated in this code lab, right? So here we have
I'm going to provide that as well. That's a very good point. I'm going to provide that as well. So you get the slides, the collab, and the data sets. You get a train data set is a JSON file, the test data set, JSON file, and the evaluate data set. And we'll go through that. That's a very good observation. All right. So during training, what we're doing is we're iterating over how many times we can improve the accuracy and reduce, bias, for example, of our data set, right? The number of training iterations, in this case, 20, sort of is correlated to how well our model performs. Also, batch size will correlate to how many batches it will take to do the training, correlates to how well it performs. It actually will help us reduce, model overfitting. I'll get into that a little bit. Again, I'm taking this path and training y'all about NLP the traditional way so that you can sort of map it to any other machine learning project and not just an NLP project, because Spacey does things a little differently. Okay, so there's some intentionality here. All right. And so then we test it. So let's actually run this. I hope it works. This is where, all right. So why, if you're looking at this little prompt over here, why isn't my credit card working. I am using this one. All right, so let's do a fake credit card. 400 1234 5348, whatever, 0000. Okay, and we hit enter. Oh God, it's not working. All right, why isn't it working? All right, so remember I said something about, how many times we iterate it, right? So we can actually, I don't want to, I don't want to increase the training iterations too much, as Alex will attest to. Right before I had trained a really large version of this, which we'll get to in a second, and it took maybe close to 2 hours to finish. So we're gonna take some risks here, Alex. Please keep your fingers crossed. If this doesn't work, I'm gonna jump back to the slides, and so I'm gonna increase the number of iterations, right? How many times it back propagates and just runs it through again, and then we're gonna increase the batch size. All right, let's run it again.
So essentially, like, it didn't work right now just because there isn't enough training data, right?
There isn't enough training data. That's a very good observation. There's just like 19 of these. And then also, we didn't run it through the training process enough times, another way to put it, right? Yeah. And so, oh gosh, I should have just copied and pasted this part, but hey, why is my credit card? Do I have a thing in there? Okay, good. I did have this in my thing. Okay, so increasing the batch size and the training iterations did it. So again, just to cover this, the amount of times we ran this model mattered in this case. We still don't have enough data, and that's going to be a problem later. You'll see. I can predict. But now what we're doing, the first accomplishment of the day, is that this string that I'm using to test this stuff is actually working. Now our blank model only predicts one thing. It still won't predict what a name is, what a place is, but we are getting somewhere. We know what a credit card is. Actually, I see a problem. It didn't pick up the 4,000 part. All right. So then we would want to throw a lot more data at it, right? So I'm gonna let me see. Let me just run this and see what we get. So I sort of try to give it different kinds of data in this example. It's the same data to try to fix the problem above right before this presentation. And I noticed that now it recognized what West Philadelphia was, right? But it's hallucinating, right? Like as they say, it's actually not hallucinating at all. It's just overfitting. It sees a pattern here. It thinks this pattern is credit card. It's just been trained on credit card. Again, to your point, Alex, not enough data, right? And so we need to fix that. And a couple of ways you can do that. Obviously, the first option is to go back and annotate more data, increase the size and variety of your data. That will fix it. In this case, I did that, and I even extended it to then train it. Hey, I want it to know that Noble Ackerson is actually a person. I want it to know that West Philadelphia is actually a place, right? So on this training set, it knows that. Obviously, you would have a lot more of this type of data. I said $25 is money. Ghanaian is a nationality. Quantity is 2 pounds of corn, right? And then let's run that.
So essentially, like, model overfitting is when data, like, model stops working correctly, right? And it labels different parts, I guess, incorrectly.
Model overfitting is when there's limited training data. The model may learn to only recognize specific patterns present in the training examples that you provided. Okay. So leads to like, weird oddities. And it's very non-deterministic, so you don't know what you're going to get, right? It's going to show you things like Noble Ackerson is a credit card, which is silly, right? And so in our case, we're seeing this because we just don't have enough variety in our data. So what we're doing is just we're adding additional variety, right? Like you're saying, all right, Noble Atkinson is not a credit card, it's a person, and just sort of teaching it. Again, this is not enough data, but for the sake of training time, we're using that. And it worked, right? In this case, I used a different name, very different, a non-American name, but it's still recognized that this person was, and this last name is one of my cousin's last name, and knows what Ghana is and knows what a credit card is as well. So now we're almost back to where we started with the medium model. And now our model knows what it used to know and what it does know, but it's still not perfect. We're seeing that it calls Bel Air a credit card. All right, so we now at least know how to fix it. Just add more training data to fix that. Mm-hmm. All right, now in real world, as you probably may have noticed, we're not. Oh, by the way, another point on overfitting. You may have noticed earlier that it's kept on doing these losses, and that's because here in our code, I wanted to print out our loss functions. You might wonder, like, what are loss functions? So a loss function is like when we're measuring, it's basically we're measuring the error between the predicted model output, this is a credit card, of our with the actual output. So what it detected, or what was in our training data, and what it actually predicted, right? In our case, we will see our loss decrease over time, which means our model is predicting the error, right? An analog for loss is our error. So it should decrease over time, which will then give us, if it's doing it right, that sort of correlates to a better performing model that's being trained. I forgot to mention that earlier. All right, so let's bring this all together, right? In real world, we are probably not going to be pasting stuff from our label studio or annotating tool. We're going to be loading something from our cloud storage, GCP or S3. In this case, I just have a JSON file, which I will provide you access to. I'm not going to run this again because it takes a very, it takes a very long time. Oh no. Yeah, okay. It takes a very long time to run. And then when it does run, it actually, so we're doing the same thing we did before. We're training it. This time we increased the number of iterations to 100. That takes almost like 2 hours. But the most important part about this, which is you've already seen this code, is that we're now saving our model to disk, and we're saving it back to Google Drive, right? In this case. Or if you have a lot of memory, you can save it to memory just for experimentation. And then we're loading that model again, right, in order to sort of better evaluate the performance of it. Okay. Overall, on paper, this is I try to spit out our evaluation measures, like the scores of it. A 1 is good. So on paper, it did really good in predicting credit card when we trained that, for 100 iterations. It looks like it did that. We didn't really have it predict. I forgot to let it predict anything else like names in our final run. And then I'm also going to spit out a confusion matrix, which is this guy right here. And I'll explain that here in a second. Think of let me explain it now. Think of a confusion matrix as a report card that tells you how well your prediction did. So if you're, I was struggling to explain this to Alex yesterday. Say you're trying to predict if it's going to rain tomorrow. You have two possibilities. It will rain or it won't rain. The confusion matrix will do two things. If it's true positive, your model will say, yes, it actually rained. And this is like answering a question correctly, right? And if it's true negative, your model predicted that it will rain, but it didn't rain. So that's a true negative. I'm hoping I get this right. So confusing. Confusion matrix are confusing. Go figure. I think I got it right. And then false positives, your model predicted that it will rain, but it didn't rain. So that's different from true negative. It's like your model predicted that it wouldn't rain and it didn't rain, right? Hopefully I haven't like, if the brain ooze is coming out, let's just ignore it. That's a confusion matrix. Look it up. And so we're going to do that. And that's this guy, right? What we're showing here is I'm using something called Seaborn to visualize this because it's the only library that I could see to do it pretty for you guys. But traditionally, you want to know how many instances where the label or credit card was correctly identified as a second label. And in this case, there were 200 instances. Like I said, there were 19 sentences in our corpus, right? And so again, it's not enough data, but it predicted, in our evaluation, we predicted credit card correctly, as you can see here, actually. And you notice that this credit card that it picked up from our data set, right? So I mounted the evaluation data and it picked up for a data set is different from anything that we've seen. In this case, it's just a string of numbers that is equal to the amount of characters in a credit card. So this data was a little bit more diverse. And our classification report also gives us our F1 score, like, you know, that our model of 1 and our model is performing perfectly on credit card, which is actually shocking for me. And then we can test it. The way I tested it was to then we'll go full circle to go back to this where we started was to feed it. I'm actually going to sort of switch back to slides, right? And sort of summarize. We identified before we deploy. Identify the right use case. We annotated our data, right? Or at least we took a shortcut in doing that. We trained it. We got lucky with a weird issue, and we fixed it. We increased the batch size. We increased the amount of training runs. And so now we can integrate it with our, I don't know, our help desk portal chatbot. All right. So here we're moving from natural language processing development to NLP engineering. So natural language processing engineering, or from ML development to ML engineering. I just want to make that distinction. And it requires similar but distinct skill sets, more aligned to, say, DevOps or, you know, more engineering focused disciplines. So in some cases, you may have the skills for both. In some cases, you may have a team that you would sort of ship your code to, or package your code, Dockerize it, and they'll pick it up. It's part of a pipeline. We'll get into that. A quick and dirty way that I used was using Fast API for this demo. But in production, you won't have that luxury. You will use an MLOps pipeline, such as Vertex AI. Definitely check that out, or TensorFlow, or TFX, they call it, TensorFlow Extended. Or one of my favorite tools, ZenML. You can leverage that. How are we doing on time? All right, so we're just about an hour. You can use
sometimes, so all good.
Yeah, ZenML, which allows you to swap in different orchestrators like MLflow or deployers like Selden for NLP purposes. But more than likely, if you're joining an existing team, there's a pipeline that they use, and you just have to learn that pipeline or learn how your model gets ingested and used within. And when I say pipeline, it's different from the NLP pipeline. It's more broader, you know, your ingest from your annotation, pre-process work, processing work, in training, post-training, deployment, right? So the entire life cycle of a machine learning project. In this case, I'm using Dialogflow, where first I'm using Fast API to create an endpoint that accepts a post I'm using dialog flow fulfillment to serve my endpoint and listen for any entities. My entity is called credit card leak, very creative naming in this case. And that I can probably show briefly. Um, yeah, I don't know. Yeah, just it's literally the same code as what you just saw. So basically, let me see. Yeah. So yeah, I think I already explained this. Our call model is accepting a post. This is our URI using Cloud Run to sort of generate an IP address for that endpoint, so it can be publicly accessible by Dialogflow. And yeah, he obviously uses Firebase. These are sort of stubbed code in that fulfillment screen that I just showed here, and I just modified that with our specific needs. The previous Fast API code does a lot of what we actually need, with letting our front end service know when the start, which in this case our chatbot, know when the text is, the starting character, the ending character, and of course our entities. For our entities. All right, so we're going to sort of go to the third and final part of this demo, which is the use cases. Any questions? Give me some time to drink some water.
There was one question about Spacey. So is Spacey a pre-trained model, or have we trained the neural net? I'm not entirely sure about the second portion of the question, but yeah.
So Spacey comes pre-packaged with pre-trained models. So I showed you one, which was the English version of their large language model, the medium version of it. They have a small version of it, which is only like 12 million parameters. Then they have like a massive version, which is the largest, like 180 million parameters or something. Don't quote me on the numbers. Then there's the transformer version. So it's like N core web _ TRF. And that is a BERT-based large language model. And so to run that on Colab, you would certainly need to switch to GPU because it takes a lot of time. It's a lot of time. I wouldn't advise anyone to run that on a regular laptop unless you have a very powerful rig, but it's very expensive to run.
So yeah, as Noble said, this is like the final section of the presentation. So about potential applications of NLP in the industry. So, and just kind of to give to the audience, to give you a little bit better overview. So like these are the potential portfolio project ideas for you, right? And then you can build something similar on your own, like after the session ends. So essentially, by using the concepts that we learned today, you will be able to build things like that. So yeah.
Excellent. All right, so named entity recognition, right? We just learned all about it, to detect and extract places, people, or even custom things, anything that you wanted out of a corpus of text or a corpus. It can be used for healthcare. So the example that I gave at the very beginning was actually a health agency under HHS, right? So that was actually a demo that I had done for them. And so, but for healthcare, it can be named entity recognition can be used to extract specific information about clinical documents, disease names, medicine names, I guess, the ingredients in the medicine, if you want, dosages, and all of that can be used to populate electronic health records, right, in the real world. So EHR records, you've probably heard of it mentioned that way. And all of that sort of supports clinical decision making for providers, and in our case, a health agency in the United States. All right, so that's healthcare. Lawyers, or in the legal context, it can be used for contract analysis. So you identify who's involved in a lawsuit, or like the parties, dates, important dates in the documents. You'd sort of train to recognize specific kinds of, I don't know, contract terms in there, and go through and annotate it, feed that into your custom NER model, using whatever library you want, or just use the Google Natural Language API to do that. And you'll be able to aid in contract management and analysis by looking at named entity recognition in the legal context. If you've ever looked at a legal agreement and wondered, what does half of this mean? In corporate world, there's an increase in automating understanding of entities within those documents. So use cases for sentiment analysis. That's nothing to do with named entity recognition. It's a completely different field. You can play around with it on Google Cloud. I just basically took a screenshot of what's available for anybody to play with, right? You just have to prove you're human. And you click on this link, or you go to this URL, you can actually sort of see the sentiment of a corpus of text to tell you if it's a negative sentiment, or if it's a neutral sentiment, or if it's a positive sentiment, and it'll score it accordingly based on its confidence and magnitude of it. We've all used Google Translate, but in corporate world, you can imagine a multinational corporation that needs to sort of summarize the context of a meeting in different language, an important meeting in different languages, or translating important documents to different field offices around the world. Of course, named entity recognition is not unique to Spacey. NLTK is another. If you want to go open source, Google's natural language API makes it a lot easier than what we had to go through the last hour or so. And with that, just a little over an hour, I'll take your questions. But before I do, that QR code leads to my link tree that has all of my links. Mm-hmm. I'm going to keep working on and improving this workshop. You'll see different versions of it, versions for specifically like transformer models version of it. And I'll try to record a YouTube video for those. So follow that. There's a Medium. I always write blogs. I always start with a tweet, and if it gets some traction, I'll write a blog post about it. And if that gets some traction, I'll do a public speaking engagement. In this case, my last Medium post is going to be live this fall. I'm going to be going around the country talking about reliability and trustworthiness of generative AI models. So follow this Medium page for that. But for you right now, what you can take away is better understand what a language model is. There's a very good explainer on Google Cloud. This slide will be linked, and you'll be able to click on it. There's a cloud skills boost if you want to get a little bit more confident before you start your project. I just went through this myself a couple months back. It's great skills boost. Get that badge. And if you want to sort of take it one step further, take a look at how TensorFlow uses NLP. And with that, I will take your questions.
Cool. Thank you so much, Noble, for the great workshop. If there were questions like how can we learn more about it, but you just provided the resources. Again, as I mentioned, like in the comments, during the workshop, we'll attach the slide, the link to the slides and code lab and the event description, so you will be able to go there and find all of the links here. Also, I just shared the link to our previous session. So the first session of this Build Your ML Portfolio series, it is where we. So during that session, we covered all of the basics essentially, and there is a link to a 15-hour bootcamp about ML. So That bootcamp was developed by Google and it's free. So I do suggest you check that out and complete it. Just to get familiarized with all the ML concepts, and then you will have a better picture and better understanding of everything as well. So and yeah, I think most of the questions were answered as we were going through. So, and yeah,
I
I guess.
can I can leave you all with some. I'm going to riff on some closing thoughts. I probably shouldn't do this, but look. So this whole demo was, I have to qualify that I used a traditional machine learning approach because this is building a portfolio on machine learning, right?
Mhm.
I should mention that if you wanted to use Spacey the right way, you wouldn't train your source input data with a CSV or JSON file directly. Spacey 3, the latest version of Spacey, has added a lot of optimizations and now requires converting your source files into something called a .spacey file. So like when instead of ingesting a JSON file like we did, you'd be ingesting a Spacey file. And that creates something called a doc bin. I don't want to get into all of that. But if you're interested in Spacey, definitely go check out their documentation. This is intentional, the way I structured this lab. And so just keep that in mind. What else can I share? Oh, be sure in practice, like when you are working for me and at my company, or you're working for someone, or you're working for yourself and starting your great startup, hire me, by the way. Be sure to include for your projects or machine learning projects, even with an NLP, clear documentation on how your models were developed. I didn't mention this before. It's very important. What data was used, the lineage, the provenance of it, what limitations were present. And for example, use model cards. Like, IBM Research has a framework for model cards. You can probably look up what a model card is. It's another thing. I do a lot of speaking at the very beginning when I introduce myself. It says something about responsible use of AI. You've probably heard that a lot, and you're like, what is it? It is a lot of things to a lot of people, but it's literally making sure that your end product does not cause harm, and that it increases trust, and people actually use it, right? So you want to make your models interpretable as much as possible. It's very complex with natural language processing models. That's why we don't really know where ChatGPT got its answers from still, and it's still an area of research. But there are libraries that you can use like SHAP or Lime for less complex machine learning or natural language applications. And then finally, back to responsible delivery of your tools. At my full-time job, I founded something called the Human-Centered AI Practice, or Human-Centered AI at Ventera. And again, the focus is to increase trust in AI, providing clear documentation, have our models be explainable and interpretable, and that it's free of bias or fairness. And I did not mention that earlier during the demo, but I think we have a little bit of time, so I just wanted to close out with that.
Mm-hmm. Yeah, there is actually one technical question that we just received. So when should you use ML techniques like the ones you illustrated today versus sorry, versus using regexes, word shapes, and other fancy words?
Yeah. I think I touched upon that in the beginning. Just because you can use AI doesn't mean you always should. And I always bias to using a simpler method to solve my problem. So, for example, by the way I understand the question for regex, if you're a front-end developer, you have validation in form entry, for example. So if you remember at the beginning, I mentioned there are some use cases where you can use let's start with a non-technical example. You can just put an annoying banner, do not input your credit card in there. Test it. do an A/B test, see whether that increases over a period of time. If
Mhm.
that does not affect change in the direction of change that you want, you may want to go with a tried and true process like a regex solution, which is basically a way to help validate that the only inputs that you send back to your service or your database is sanitized in a way that protects the user and protects your system. So you would use a regex to prevent cross-site scripting, or in this case, in this example, you would use regex to prevent someone from entering a credit card. The problem is, as I mentioned in the very beginning, is that for some use cases, rule-based approaches to clean up your inputs on the front end become very complex, right? I used the phone number, for example. You would have to have a regex that accounts for and parenthesized phone numbers, non-parenthesized phone numbers, spaces in phone numbers, dots in phone numbers, God knows a misspelling of a phone number. So this is where an AI may choose. Again, we use this as an example, but that's a very, very good question. Yeah.
Mm-hmm. Yeah. Okay. I guess there is one more about logs. Is there a way to speak about logs as the model is making predictions?
Yes. And I actually showed one way to do that. I sort of showed my loss function just so I could see if, as it was running, as it was making its predictions, to sort of see its progression, whether it was actually getting worse or getting better. In our case, it was actually getting better and knowing what a credit card was. And so during your evaluation stage, you have a lot of methods to spew out what it's doing. And it's very, if not, it will be very black box, and you'll wait for an hour and then you come back and you go, wait, let's do this again.
Okay, I guess that's it for the questions for today then. Just as a final note, I guess, please do join our chapter, GDG chapter Waterloo. Next, in 2 weeks, we'll have another session, a similar one about computer vision. Yep, thank you so much for joining, everyone, and thank you so much, Noble, for giving a great presentation and sharing valuable information with us. So, yep, have a great weekend, everyone, and hope to see you in 2 weeks. Yeah.